Hey y'all, Professor Wyman here. I am in the data set that we created where I collected data from you this semester, and I'm looking at age, which is a continuous variable. So this video, I'm just going to talk about how to interpret this output from Jamovi. So again, we have a continuous variable, and there's certain types of statistics that we'll calculate using using Jamovi that are appropriate for a continuous variable. So you're going to see here that first of all, this tells us how many people are in our sample. So this number right here, n equals 36, means that there are 36 people in our sample. Now, out of those 36 people, there are no missing values for age. So this means that because it's a zero, it means that everyone in that data set, all 36 people, gave their age. So that's included there. The next part, the mean and the median, are measures of central tendency. So measures of central tendency tell us about the center of the data set, or tell us about the norm or what is common in our data set. And so in this case, our mean is 21.86 and our median is 20.50. So the way to interpret that is that the mean, so the mean is typically a capital M, or you might see a X bar. That's for a sample mean. So the mean is 21.86. I'm going to round it up to two numbers after the decimal. So 21.86. And this is telling me that if I were to add together everybody's age in the data set and divide it by 36, this is the number that I would get. So you can kind of think of it as fairness. If everybody had the same number of years of age, this is what it would be based on the responses in this data set. Now the next one that we're looking at, the median. The median is particularly helpful if we have a skewed distribution. And so the median here, Jamovi automatically gives us that information when we put age in as our variable. We can see that the median age is 20.50. So this is different from the mean. The median would be if I were to line everybody up by their ages from youngest to oldest, and then I found the middle person, or in this case, the two middle people, because this is a 36-person data set, it's even. So the two people in the middle, I would get the average of their ages, and that's the 20.50. So we probably had a 20-year-old and a 21-year-old, and so the average is 20.50. So because the median is lower than the mean, that suggests that we might have a skewed distribution, which you might have noticed already in the graph. So when we have a lot more younger people in the data set, and then just a few who are older, we get this positively or right skewed distribution here. And so when we have a positively skewed distribution, our mean is going to be higher than our median. It's getting pulled up away from the center of the distribution, and it's going to be higher than that center value. So the median, again, is that it cuts your data set in half. So we can see that the mean is a little bit higher than that, so it's not perfectly symmetrical. The other information here that I care about, right there, standard deviation, that is a measure of variability. Now, others that you might talk about are the variance, which is the squared standard deviation. You also could talk about interquartile range, or you could talk about range, which is just the maximum minus the minimum. Honestly, with continuous variables, we most frequently talk about standard deviation. So again, like I talked about in class, you want to think about like your mean and standard deviation holding hands through life. You're going to report them together. So that way you can talk about what the center of the data set is using your measure of central tendency, and then measure of variability tells you how spread out that data set is from the mean in this case. So the standard deviation, which is this 4.11, the standard deviation here means that on average, people in the data set vary by about 4 years from the mean of 21.86. So if you think of the mean of this 21.86, you're going to have some people who are a little bit older. You're going to have some people who are a lot older. You have some people who are younger. But essentially, what the concept is that the overall average distance between everyone and the mean is about 4 years. So this, again, it tells us something about the distance or the variability in our data set. So if we had a standard deviation of only 1 year, we would say that there's a lot less variability. People are kind of closer to the mean in their ages. The last little bit here, we do include the minimum maximum are automatically included in Jamovi when you choose to analyze a variable. And so this 18 years is just the youngest age recorded, and the maximum is the oldest age recorded. So it's helpful. You might even report it just depending on what you're talking about. But generally speaking, it's not as important as talking about our central tendency and our measure of variability. So those are typically the statistics that we report for a continuous variable. The next video, I'm going to talk about the graphs for a continuous variable, but this should give you what you need to know for analyzing the continuous variables in Jamovi and then understanding the results.